Hello everyone, myself Sanjeevani Surendra Chaudhary. Today's my seminar topic is Bragg's method of X-ray diffraction and Debye Sherrer method. In this method we will discussing about X-ray diffraction, Bragg's law, Bragg's equation, application of Bragg's law, Debye Sherrer method and application of X-ray diffraction. In this we have to discuss X-ray. So X-ray is a short wavelength electromagnetic radiation produced by the deceleration of high energy electron. So it is used to produce an electron from the inner shell orbital. Let's consider these are the orbitals. When the high energy electron beam is incident on the inner shell orbital, it ejects the inner shell electron. It is called as X-ray. So there are the different penetration power of X-ray. Hard X-ray and soft X-ray. The hard X-ray is which have the high frequency and have the more energy, and soft X-ray which have the less penetration power and have the low energy. Then diffraction. Diffraction is a wave phenomena in which the apparent bending and spreading of the wave when they meet to the obstruction. Consider these are the surface. When the X-ray is incident on the surface, it is not transmitted to through it. It is diffracted in the many direction. It is called as diffraction. Then the X-ray diffraction. It is a technique which is used to determine the atomic and molecular structure of a crystal, in which the crystalline atoms cause a beam of incident X-ray to diffract into the many specific directions. So consider this. This is the crystal. When the X-ray is incident on this crystal, it is diffracted in the many directions, and this method is used for the determine the atomic and molecular structure of a crystal. Then Bragg's law. Bragg's law gives the angle for the coherent and incoherent scattering from a crystal lattice. When the X-ray are the incident on an atom, they make a electronic cloud move as does any electromagnetic wave. The movement of these charges radiates the wave with a frequency is known as relay scattering. First of all, what is the relay scattering? The relay scattering which have the same frequency of the incident light and reflected light. So consider this is the molecule. When the X-ray is incident on it, it is transmitted with the same frequency or energy. There is no exchange of energy takes place. Then Bragg's law. So Bragg's law consists of various apparatus such as X-ray tube, filter, collimators, crystal and detector. When the X-ray is incident on the crystal from a X-ray tube, which is transmitted through the filter and collimator, which is when it is incident on the crystal, it is diffracted, and this diffracted ray is detected in the detector. Then a similar process occurs upon the scattering neutron wave from the nuclei. This re-emitted wave field interfere with each other either constructively or destructively, producing a diffraction pattern on a detector or film. The resulting wave interfering pattern is the basis of the diffraction analysis. The analysis is called as Bragg's diffraction. Then there are the two layers of the crystal is present, which is denoted by alpha and beta. And there are two incident light A and B, which is incident on a surface and which is diffracted in the two wave C and D, which is denoted by C and D. There is form a perpendicular which is denoted by OY, and form a line X and Z. So there are the angle XOY is equal to theta and ZOY is equal to theta. So what is the theta? Theta is the glancing angle. So glancing angle is the angle between the incident light and the surface. It's called as glancing angle. So consider the AO is equal to BX and CO is equal to DZ. There is a part difference is present. So XY plus YZ. So what is the path difference? Path difference is defined as the integral multiple of a wavelength, which is denoted by n lambda. So n lambda is equal to xy plus yz. So there is a angle is present sin theta is equal to length of the perpendicular upon hypotenuse. So now in the triangle XOY, sin theta is equal to xy upon OY. So there is xy is length of perpendicular and OY is the hypotenuse. So rearrange this, xy is equal to oy into sin theta. So value of oy is equal to d, which d is the angle between the two layers of the crystal. Then second, del is equal to zoy, sin theta is equal to zy upon oy. So zy is equal to oy into sin theta. The value of oy is equal to d sin theta. So put the value of xy and zy in the equation number 3. So n lambda is equal to d sin theta plus d sin theta. N lambda is equal to 2d sin theta. This is the real equation of Bragg's law, where the n is the order of diffraction. In this, order of diffraction is 2 because the two layer of crystal is present, and lambda is equal to wavelength of X-ray, and d is a interplanar distance. Theta is equal to the glancing angle, and there are the different angle for the sin theta is present: 0, 30, 45, 60 and 90. So sin 0 is equal to 0, sin 30 is equal to 1 by 2, sin 45 is equal to 1 upon root 2, sin 60 is equal to root 3 by 2, and sin 90 is equal to 1. Then application of Bragg's law. Bragg's law is used for the many of the purposes. So the solving the Bragg's equation gives the d spacing between the crystal lattice plane of atom that produce the constructive interference. A given unknown crystal is expected to have the many rational planes of an atom in its structure. In the X-ray diffraction, the interplanar spacing of a crystal is used for the identification and characterization purpose. This Bragg's law also used to scan the image inside the body with the help of the Bragg's law. Then the ultrasound use the echoes from the sound wave to locate the different organ inside the body and can be used to monitor the growth of the unborn baby. Then the MRI and NMR use the powerful magnet to measure the water content of the different types of the body tissue and show the process, but they generate the incredible detailed image of the body. Then the fifth application is positron image topography, which used to detect the radioactive traces that are injected into the body, and EEG detect the electrical activity in the brain. Then Debye Sherrer method. In this Debye Sherrer method, powder specimen is used instead of a single crystal. Then here is no need to rotate the specimen because there will be always some crystal at an orientation for which diffraction is permitted. Means there is no there are many micro crystal are present inside the powder. So in this, in the capillary small amount of sample is present, and this capillary is put in the middle of the camera, and when the X-ray is transmitted incident on this capillary, it is diffracted into a different direction. This it form the cones of the diffraction. These cones intersect a strip of the photographic film located in the cylindrical camera to produce a characteristic set of the arc on the film. Now consider there is a small capillary is present. In this, the sample powder sample is present. When the incident light is incident on this powder, it is diffracted in the various direction. It form a cone. This method is called as Debye Sherrer method. Then this powder diffraction film, when the film is removed from the camera, filter and process, it shows the diffraction lines and the holes for the incident and transmitted beams. Then the application of X-ray diffraction. There are various applications of X-ray diffraction. It is used for the differentiation between the crystalline and amorphous material, and determination of structure of a crystal material, determination of electron distribution within the atoms and throughout the unit cell, the determination of orientation of single crystal, determination of texture of a polygrain material, and measurement of strain and the sample grain size. Thank you.